In this video, I'd like to look at some examples of how we can find different angles in a parallelogram. Remember that a parallelogram has 4 important characteristics that you need to learn. In a parallelogram, both pairs of opposite sides are equal. Both pairs of opposite sides are parallel. Both pairs of opposite angles are equal. And the diagonals bisect each other. Also, just like all quadrilaterals, the interior angles add up to 360 degrees. Let's look at an example. Determine the value of x and then classify quadrilateral ABCD. We may not know what type of quadrilateral this is, but we do know that it's a quadrilateral because it has 4 sides. And we know that the interior angles of a quadrilateral always add up to 360 degrees. So let's add up all the interior angles in the shape. So we can say angle A, let's say 3x plus 13 degrees. We have angle D, so we can say plus 4x minus 36 degrees. Angle B, 3x minus 7, so we say plus 3x minus 7. And angle C, 2x plus 42. I'm going to write it down here. Plus 2x plus 42 degrees is equal to 360 degrees. We know that the interior angles of a quadrilateral add up to 360 degrees. So as our reason, we say the interior angles of a quadrilateral. Now we've created an equation we can use to solve for x. So let's start by adding like terms. 3x plus 4x is 7x, plus 3x is 10x, plus 2x gives us 12x. You can say 12x. Now we have 13 degrees minus 36 degrees, which gives us negative 23 degrees, minus 7, which gives us negative 30, plus 42 gives us positive 12 degrees. Then we make this equal to 360 degrees. Now to get our x term by itself, let's move the 12 to the right. So we now have 12x is equal to 360 minus 12, which leaves us with 348 degrees. Now to get x by itself, we need to divide both sides by 12. So let's take our calculator and we can say 348 divided by 12 and we get 29. That means that x must be 29 degrees. Now we have the value of x, but we still need to classify the quadrilateral. This means we need to determine what type of quadrilateral this is. We don't know anything about the lengths of the sides, but now that we have a value for x, we can find the sizes of each interior angle. So let's make some space, and we can make a note that x is 29 degrees. Now let's start by finding angle A. So we can say angle A is equal to 3x plus 13 degrees. We know that x is 29, so we can say 3 multiplied by 29 degrees plus 13 degrees. Let's expand our bracket and we get 3 multiplied by 9 is 27. 3 multiplied by 2 is 6. Add 2, we get 8. It's 87 degrees plus 13 degrees, which gives us a total of 100 degrees. This is the size of angle A. So let's make some space. Let's take 3x plus 13 out of our diagram and fill in 100 degrees. Now we can look at the size of angle B. So we can say angle B is equal to 3x minus 7 degrees. X is 29 degrees, so we can say 3 multiplied by 29 degrees minus 7 degrees. We just found that 3 multiplied by 29 is 87 degrees. Then we minus 7 degrees, and we get a total of 80 degrees. This is the size of angle B. So again, let's make some space. Let's take out 3x minus 7, and we can fill in 80 degrees. Next, let's find angle C. So we can say angle C is equal to 2x plus 42 degrees. We know that x is 29, so we can say 2 multiplied by 29 degrees plus 42 degrees. 2 multiplied by 29 gives us 58 degrees plus 42 degrees, and we get a total of 100 degrees. This is the size of angle C. So let's make some space. Let's take out 2x plus 42 degrees and fill in 100 degrees. Finally, let's find the size of angle D. So we can say angle D is equal to 4x minus 36 degrees. Let's substitute 29 into our x value, and we get 4 multiplied by 29 degrees minus 36 degrees. Now we need to expand the bracket. 4 multiplied by 9 gives us 36. 4 multiplied by 2 is 8, plus 3 gives us 11. That's 116 degrees minus 36 degrees. And we get a total of 80 degrees. This is the size of angle D. So finally, let's make some space. Let's take out 4x minus 36 and fill 80 degrees into our diagram. Now we have the values of all of the interior angles. We know from our work on angle relationships that if two lines are parallel, then co-interior angles are supplementary. They add up to 180 degrees. But we can also use co-interior angles to prove that two lines are parallel. Let's see if AD is parallel to BC. So let's make these two sides blue. Now a transversal line cuts both parallel lines. And here we have two transversal lines, AB and DC. We're going to use AB. So let's make this line purple. Co-interior angles lie between parallel lines on the same side of a transversal line. So we need to consider angle A and angle B. Let's add these angles together. So we can say angle A plus angle B is equal to 100 degrees plus 80 degrees, which gives us a total of 180 degrees. These co-interior angles are supplementary, which means that AD must be parallel to BC. And as our reason, we say co-interior angles are supplementary. Now let's make some space. Let's make our diagram black again. And let's put a small arrow on side AD and a small arrow on side BC to show that these sides are parallel. Now we know from our previous video that a trapezium has one pair of opposite sides that are parallel. So this might be a trapezium, but glancing at the diagram, we cannot really tell whether or not AB is parallel to DC. So we need to check. Let's make side AB and DC blue. Again, we have two transversal lines, AD and BC. We're going to use side AD, so let's make it purple. Remember that co-interior angles lie between parallel lines on the same side of the transversal line. So now we can consider angle A and angle D. So we can say angle A plus angle D, which is equal to 100 degrees plus 80 degrees, which we know gives us 180 degrees. These co-interior angles also add up to 180 degrees, which means that AB is parallel to CD because the co-interior angles are supplementary. Now we can make some space and make our diagram black again. AB is parallel to CD. So on our diagram, let's put 2 blue arrows on AB and on CD as well. This quadrilateral has 2 pairs of opposite sides that are parallel. So as our final answer, we can say ABCD is a parallelogram because 2 pairs of opposite sides are parallel. Let's do another example. Given parallelogram EFGH with EI bisecting angle E and JG bisecting angle G, find the size of every interior angle in terms of Y. Don't be scared to draw on your diagrams. So before we try and tackle this question, let's make a note of the given information on the diagram. The question tells us that EI bisects angle E. This means it cuts angle E in half, which means that angle E1 is equal to angle E2. So let's mark these angles in blue. The question also tells us that JG bisects angle G. This means the size of angle G1 is equal to angle G2. So let's mark these angles in green. Now we can find the values of the interior angles. The question tells us that angle E1 is equal to Y. This information has been given to us, so we use given as our reason. We know that angle E2 is equal to angle E1. So both of these angles are equal to Y. And we know this because EI bisects angle E. And this information has also been given to us in the question. Now on our diagram, let's clean up angle E1. We know that E1 is Y, so we can fill in Y. We also know that E2 is equal to Y, so let's clean up this angle and write Y on our diagram as well. Now the question tells us that EFGH is a parallelogram, so let's make the whole shape red. In the beginning of this video, we learned that in a parallelogram, opposite angles are equal. This means the whole of angle E, let's mark it in purple, is equal to the whole of angle G. So let's mark it in purple as well. Now we can make the statement that angle G is equal to angle E because they are opposite angles of a parallelogram and we know that these are equal. Now angle E is made up of Y and Y. So angle E is equal to 2Y, which means that angle G must be equal to 2Y as well. We also know that angle G1 is equal to angle G2. And this is because JG bisects angle G. And we know that this is true because this information has been given to us in the question. Now, if line JG bisects angle G and cuts it in half, This means that angle G1 is not only equal to angle G2, but both of these angles are equal to y. Now let's take our purple arcs out of the diagram. Let's tidy up angle G1 and we can fill in y. Now we can tidy up angle G2 and fill in y as well. Now let's make our diagram black again and we can make some space. We know that we can use parallel lines and transversal lines to find angle relationships. EFGH is a parallelogram, which means that both pairs of opposite sides are parallel. So let's look at side EF and parallel side GH. Let's make these two sides blue. EI cuts both of our parallel lines. So let's make this transversal line purple. Now we've created a Z shape. Angle E2, let's make it red. And angle I1, let's make it red as well. Both sit inside the Z shape. So these are alternative angles. We know that alternative angles are equal. So if E2 is equal to Y, then we can see that angle I1 must be equal to Y as well, because these are alternative angles. And we know that they're alternative angles because EF is parallel to HG. And this is true because both of these sides are the opposite sides of a parallelogram, which we know are parallel. Now we can take out our red arcs. Let's take out angle I1 and fill in Y. Now we can make our diagram black again. Now HIG is a side of the parallelogram. It's a straight line. So let's make the side blue again. I sits on the straight line. So let's mark this whole angle in red. We know from our work with straight lines that the whole of angle I must be 180 degrees. Angle I is made up of angle I1, which we just found to be y, and angle I2. If y plus angle I2 is equal to 180 degrees, then we can see that angle I2 must be equal to 180 degrees minus the y we just found. And we know that this is true because these angles lie on a straight line. Now we can take out our red arc, take out angle I2, and we can fill in the size of the angle as 180 degrees minus y. Now let's look at angle J. Side HG is parallel to side EF. So let's make this side blue. JG is a transversal line that cuts EF at J. So let's make this line purple. Now we've created another Z shape. Angle J2, let's make it red. And angle G, let's make it red as well. Both sit inside the Z shape. They are alternative angles, which we know are equal. So now we can make the statement that angle J2 is equal to y, because these are alternative angles. Remember, we also have to include why they're alternative angles. And this is because EF is parallel to HG. And we know that these sides are parallel because opposite sides of a parallelogram are parallel. Now let's take out our red arcs. Let's take out angle J2 and we can write down y in our diagram. Now let's make our transversal line black again. EJF is a straight line, so let's focus on this line. Angle J also sits on a straight line, so the whole of angle J must be 180 degrees. So let's mark this angle in red. Angle J1 plus y will give us a sum of 180 degrees. So we can see that angle J1 must be equal to 180 degrees minus the y we've just found. And we know that this is true because these are angles on a straight line. Now we can take out our red arc. Let's take out angle J1 and write down 180 degrees minus y. Now let's make some space and make our diagram black again.